In this video, we're going to continue looking at basic differentiation rules, and we're going to look at the constant multiple rule. So previously, we talked about the derivative of a constant all by itself is equal to 0. However, now we're going to talk about what is the derivative of a constant multiplied by some other function. And what we find is that that constant is just going to go along for the ride. When we take that derivative, we can take the derivative of the function part and just bring that constant along for the ride. Right? So here, if we look at a couple examples, we have f of x equals 3x squared. We can think of this as 3 times the function x squared. So we have this constant times the function x squared. And so our derivative, f prime of x, that constant is going to stay there. And we can take the derivative of x squared, which is 2x using our power rule. And so that derivative of 3x squared is 6x. Beautiful. If we wanted to take the derivative of 4 times the cube root of x, we could rewrite this first using algebra rules. So this is 4 times x to the 1/3 power, right? So that's how we rewrite cubes as powers. And so then our derivative, that constant is going to go along for the ride. We'll bring the power down and then subtract 1 from the power. And so we get 4/3 is the constant out in front, x to the negative 2/3, or 4 over 3x to the 2/3. Well, that's our derivative there. And if we have 5 over x, we can rewrite that as 5x to the negative first initially. And then when we take our derivative, the 5 is a constant, and we use our power rule on x to the negative first. So we bring the power down, and then we are going to subtract 1 from the power. So we have 5 times negative 1 is negative 5, x to the negative 2, or negative 5 over x squared. So that's how we can deal with constants. We have the constant multiple rule. We could also take a look at sum and differences. And so if we have the sum and difference of two functions, and we want to take the derivative of that sum or difference, then one really nice thing is we can take the derivatives of each piece individually. Right? So we can take the derivative of the first piece plus or minus the derivative of the second piece. Right? So let's look at some examples here. So if our function is 4x cubed minus 7x, our derivative is, so we can take the derivative of the 4x cubed piece by itself. And so we have the 4, power rule on x cubed, we bring the power down, and then we subtract 1 from the power. And then we can take the derivative of the 7x piece. Right? So that's 7 is the constant. The derivative of x, you can think of that as x to the first power. So it's 1x to the 0. And if we clean things up, we have 12x squared minus 7x to the 0, which is just 1. So 7 times 1. And that is our derivative. Perfect. That's our derivative there. Right? Notice we just took the derivative of each piece individually, and then we took the difference between those. And we can do that with any number of different pieces, right? So here on this next one, f prime of x. All right, so before I do this, I might rewrite this so we have x raised to powers. So we have x to the 1/2, that's what a square root is, plus 3x to the negative 5th minus 423. So when we take the derivative of the first piece, we have 6. So the constant goes along for the ride when it's a constant times something else. And we have our power rule for x to the 1/2, so we bring the power down. And then we subtract 1 from the power. Then we add to it the derivative of the next piece. So there we have the 3 goes along for the ride. We bring the power down. And then subtract 1 from the power. And then negative 423, that is a constant all by itself. And so when you take the derivative of that constant, it's just 0. Now, if it was a constant times some other function, it would be that constant times the derivative of the other function. But it's all by itself. And if we clean this up, we have 6 times 1/2 is 3. We'll have x to the negative 1/2. 3 times negative 5 is negative 15. X to the negative 6th. And then that 0 goes away. And we could clean this up still. Get rid of negative exponents. So we could write this as 3 over the square root of x minus 15 over x to the 6th. And that is our derivative. Fantastic. In our next video, we will take a look at derivatives of the sine and cosine functions, and we will see you there.